Absolutely. So thank you, everyone. I'm sorry my video doesn't work, but we're happy to have everyone here and a really good showing. This work is building on the STAR solar program that we've been happy to be engaged in with Resonant and MACDC and many of you for existing buildings primarily. And so we're really excited to be able to help affordable housing owners think about new developments and planning for solar as in advance. So we think that this is a great way to kick off the summer and hope that you find this useful, and happy to continue to connect on this and take any questions. And I will pass it back over to the Resonant team to get into the details. So thank you all for joining us.
Thank you, Emily. So for everyone else, for those who I have not had the opportunity to meet yet, my name is Isaac Baker. I'm the co-CEO and founder at Resonant Energy, and we are a B Corp employee-owned solar development company based in Dorchester, Massachusetts, that is dedicated to expanding access to solar to nonprofits and affordable housing. And I will tell you a little bit more about us in a moment. But first, what I wanted to do was, as Emily mentioned, we've been really excited to be collaborating for the last 2 years now with LISC and MACDC on this Solar Technical Assistance Retrofit Program, otherwise known as the STAR program, and to be expanding that into new construction. And as we have seen over the last few years, the interest from all of our kind of partners who are working in the affordable housing space in adding solar to new construction has really gone through the roof over the last 2 years in terms of folks who want to be figuring this out. So what we've decided to do to try and educate folks en masse over the course of the summer is to offer 3 free presentations so that folks have an opportunity to learn more about some of the ins and outs of how that can work with solar. As we have developed a specific point of expertise in both solar for new construction and specifically for affordable housing and the extra nuances and intricacies that that comes with. For today, we are having the Solar 101 financing and contracting that is focused for developers, but really appropriate for anybody who wants to figure out what does it mean to get into a new construction development financially. And it turns out that really the rubber hits the road at the dollars and cents, as we all know, for new construction budgets. So making sure that we have an approach that really is appropriate for the building is going to be key. And so we're going to go over today some of the financing pieces, contracting, and early stage planning for how solar can integrate with the building. Later this summer, some of my colleagues will be presenting on the solar design considerations, which would be good for architects and developers of how do you actually, some of the nitty gritty of the design. And then we'll be going through zoning and certifications, whether that be passive house or E+ or all the new things that are forthcoming, where we're going to start seeing solar being required on many more new buildings. And there's many different types of requirements for how different types of entities, whether they're typical or passive house or whomever, and how and to what extent they're requiring solar adds a new wrinkle for developers to tackle. And that's something that we have been working with developers on for the last few years and are going to be chatting about later this summer. So that is our programming in a nutshell. And without further ado, I'm going to dive into our presentation today on Solar 101 and financing. So, in terms of, by way of introduction, we're going to, as I've mentioned, Resonant Energy, we're focused on, we serve projects in Massachusetts and New York. About 60% of our work is with affordable housing. We also work with nonprofits, from schools to elder facilities and houses of worship, as just a few examples. And the way that we work is we aggregate solar projects together, create low-cost, high installations, and in particular to help leverage impact financing. And we help clients serve across the full range of options. To just offer a few examples of what these projects have looked like, we have the Madison Park up in the top left corner, who we helped install solar on 17 of their buildings in Roxbury over the last few years, and most of that with third-party financing via CDFI. South Boston, NDC, 15 sites in South Boston over the last 2 years. Dorchester Bay, that building that actually just recently sold to Commonwealth Kitchen, who had been the anchor tenant at the time we put solar there. And then just an example of many affordable housing developments don't have significant parking space, but when they do, parking canopies can be a great option in Massachusetts in particular, given the incentives. And this was an example for a faith-based client called Temple Amuna, where we actually developed a community solar parking canopy. So about half that power is going to serve low-income households and cut their energy bills, while the other half is powering the temple. Let's see. And it sounds like I'm coming through a little choppy, so I apologize for that. And hopefully the internet will not give us too much trouble here. But if it does, please let me know, and I will work to address that. Let's see, just some non-exhaustive list, but just some of the clients we worked with over the last few years, ranging from some of the larger players in the state, like the community builders and Trinity, down through many of the CDCs all across the state that we've had an opportunity to work with. And that this is where we have developed a lot of the expertise on these types of projects. So to dive in, number one, first thing we wanted to talk about is solar financing models. So question number one for most of the developers that we're working with is, what's it going to cost and how are we going to fit it in? And when we got started in this work, thinking about how solar would fit into affordable housing, what we were finding really over the last few years is that before we really entered the market and started adding a lot of the new resources that we've been bringing, the standard approach to solar was often it's not included in the budget. Sometimes it is. But really, whether sometimes we would see developers were thinking about, well, I'll spend my contingency funds on solar, so it'll be a nice to have. Or they would actually plan in the budget for solar, but in reality, when costs went up elsewhere, solar was not required to get your certificate of occupancy. So in effect, the budget that was set aside for solar was really being treated as extra contingency. And therefore, probably more than 50% of the time, we were seeing folks build solar-ready roofs with an idea that they might go back and put solar on it later, but it would often get cut because the cost of timber had skyrocketed, or any number of other issues had come up during the construction cycle that had eliminated solar. So one of our first approaches when we were thinking about how to help solve for this problem was two things. And one, for the ownership option, we found that with planning, we could actually help to avoid that. And that the second was to have a no-cost option. We look at the two most common types of financing for new construction, and one is a no-cost option, and the other is an ownership option. So to quickly talk about direct ownership, this is the model that most people are familiar with solar, and this is the most straightforward. You sign a construction contract that buys the system, where the entity that is developing the building is going to be the outright owner of the system. You get the tax credit, depreciation, incentives, electricity savings, all the rest. And in our experience, it's best if this is planned for early. So in an ideal circumstance, we'd get brought in at around 70% construction drawings. When you already know, here's where the HVAC is going to go, here's where our plumbing vents might go roughly. And so let's plan solar around that. And then let's get a line item in the budget. And then not only are we going to get a line item in the budget, but unlike other stuff that's going to go into your budget, solar actually is going to create operational savings. And so that part is really key, is to not just add, $200,000 for solar into the budget, but to also talk to your senior lender about underwriting the savings from solar, which many of them, especially in Massachusetts, where we've talked to Mass Housing Partnership, Mass Housing, and many of the other state-based lenders are very comfortable moving in this direction. And there are two revenue streams from solar, which we can chat about, but there's your electricity savings, and there's a smart cash incentive payment that's going to come to you over 10 or 20 years in Massachusetts. And both of those can be underwritten by your senior lender and can then help you basically create room in the budget for solar by allowing your senior lender to extend you more borrowing capacity on the basis of the value that solar is bringing to your building. So that's in a nutshell the best practices for when to bring you in, when to and how to talk to senior lenders about underwriting that value that solar is creating so that it has room in the budget. And then in terms of where it's best for projects where you have a tax partner. So that would be LIHTC or a historic tax credit, most commonly from what we've seen. You can include solar, and you can package the solar tax credit along with your low-income housing tax credit to effectively sell that as well. And that we've seen that be fairly successful for most of the developers we've talked to, though again, best if you plan for it early, and ideally when you put out your request for bids for your whomever is going to buy your low-income housing tax credit, that they're also prepared to buy your solar tax credit as well, and you make that part of the deal. And in most cases, folks are comfortable doing that. The direct ownership option is also most appropriate for buildings that have a tax-exempt bond financing as far as the loan and debt structure, which isn't wildly common in affordable housing, but we have seen in a set of circumstances. And the reason for that is that the tax-exempt bond structure can complicate having a third-party ownership model. There are some rules in those bonds that prevent leasing the building to third parties. So it devil's in the details, and it's worth research. So it's not a definitive no, but is clear is that it's much easier with those buildings out of the gate to just choose to purchase your solar array rather than doing it in another fashion. Now, if you don't have a tax exempt bond, and for any number of reasons, let's say you're not doing a low income housing tax credit setup, and so you don't have an active equity investor when you're building your new building, then going with the no cost option can be the right outcome. And in this no cost option, it's often referred to as a power purchase agreement, or a PPA for short. This setup, you have a third-party investor who provides 100% of the upfront and ongoing costs. So they pay for the installation of the system and then legally own and operate the system for a 20 to 25-year term with buyout options throughout. And while they are the owner, they provide all insurance and cover all insurance and maintenance costs, and generally take care of the system and monitor it. As the end user, the building will be able to buy, is required to buy all of the electricity produced by the system on site, and uses it to offset on-site electricity usage, and generally can leverage anywhere from a 20 to a 50% discount on the electricity produced by the solar array relative to what you would have paid to National Grid or Eversource, the two prevailing utilities in Massachusetts, and that you lock in effectively a starting rate with a 1 to 2% escalator over that 20 to 25-year term. And as we've seen most recently, where utility costs are skyrocketing right now, Eversource is about to nearly double the cost of basic service, which isn't even the total cost of electricity. That's just the cost for the power. So you get a hedge against those really significant cost increases that we expect to continue to see over in the coming years by just locking in a 1 to 2% escalator on your power. So the long story short of the power purchase agreement is that you're able to spend nothing up front, to lock in a discount, and to kind of have a hedge against future increases by also having a lower and predictable escalator where your power from solar is not going to fluctuate based on market prices over time. This power purchase agreement, in addition to being good for new construction where you don't have tax eligible partners, is also a good backup option. And we've actually most recently on a project with Hebrew Senior Life structured a new construction contract with them that they said, we are almost positive we're going to be able to buy this system. So let's get started and sign a contract on that basis. But what if we were able to insert a provision that said, at some point later in the construction cycle, if we find that we don't have the budget for solar anymore, what if we flip to a no cost option? And we were able to work with them to actually insert a provision, gave them terminate the and flip to a no-cost option using the exact same design we had been working on their architect and development team with. So they would still be able to go solar really either way, no matter how the budget issues worked out. And that, especially given all of the uncertainty that's happening with construction budgets right now. So those are the two most typical options that we are seeing for third-party financing. A final option that we've seen for a few new construction projects is, I'm just seeing that the video is causing a little bit of challenge here. So I'm going to try turning off my video. Let's see if that helps. So for the third-party financing models, a final option is the site lease. So for a site lease, what we are finding is this can be a good option if you have a fairly large site, whether that be a rooftop, ground site, or parking lot, where you have a lot of space to install solar that might be in excess of the total power that's needed for the building. And in this circumstance, you would pay, with this financing model, you pay nothing up front. And unlike the power purchase agreement, where the power gets used right on site, the power would actually be sent, in this case, primarily to off-site users at a 10 to 20% discount, which is something that the third-party financer would engage. And you would, as the building owner, could collect a lease payment either in the form of cash or in the form of some discounted or free power in lieu of cash, since many low-income housing tax credit deals are restricted in their ability to collect cash lease payments. So that what we found as a workaround is we can give away free electricity offsets, which financially is worth the same thing to the building, but does not trigger low-income housing tax credit issues. In terms of so that is another good option. We don't see this very commonly with new construction affordable housing, since most buildings are best suited to be able to do solar and just use all the power right on site. But especially for parking canopies, we find that you can build a lot more power than a building needs in some cases. So this can be a viable option for those setups. So that covers us for the financing options in terms of you can buy it, or you have some different ways of you can do multiple types of no-cost options depending on whether you're going to use the power on-site or off-site. The next thing we want to talk through in terms of sizing a system is estimating the energy usage. And this is something that we've spent a lot of time on, since this is a really critical part and often something that we're finding that owners don't always have a lot of insight into out of the gate. So some of these key considerations are, a lot of developers are starting to go all electric. There are incentives from utilities to do so. We're seeing more heating and cooling being moved to heat pumps. We're seeing water heating being moved to electric heat pumps. And in some cases, with the heating and cooling, having that moved to a VRF system on the common meter, as opposed to individual heat pumps. So when we think about energy usage, as we'll get into, the best buildings from a solar integration standpoint perspective are buildings where landlords have moved as much of their usage over to electric as possible and off of gas and other fuel sources. And then where they have concentrated that load all on a single meter, ideally the landlord paid common meter. And this helps us get around the landlord-tenant split incentive issues, which I'm going to talk about a little bit more on the next slide. And because solar effectively needs to tie in behind a single meter, so having a single point of load that we can tie in behind is key. And where we don't have that, as our next point here, is the solar is generally sized relative to the common area usage. So if you don't have any significant common area usage, it may be that the most economic outcome is for us to size the system down, even if the roof could hold more, just to offset the more minimal usage that the developer has chosen for the building. As part of this planning, there are different rate classes and different ways that the utility charges customers for power. based on how much power you use. So being able to anticipate this ahead of time helps us estimate your savings by designating what utility rate class you'll be assigned. And then lastly, having a clean understanding of single phase versus three-phase service for the house meter is very important, as it interacts with the net metering rules and other financial incentive rules for how solar engages with the building. So in terms of the typical buildings that we're seeing, there's kind of, I like to break them down into three types, which is that we've got the townhouse or the scattered site style development, where we're basically just seeing exterior lighting, sometimes septic or water pumps in rural areas. But basically there's no common hallways, there's no elevators, there's no generally shared space. And so there's not much in the way of electricity usage there. So we're seeing that where you might just have some common meters with a couple thousand kilowatt hours. And in that case, solar can produce far more than what the common area uses. And so with a lot of those developers, and this is something I'm talking about as an example with Island Housing out on Martha's Vineyard, a lot of their developments are necessarily not high rise for many reasons, but they're in a more in a setting where 1 to 2 story buildings are the norm, and therefore they don't have common meters. And so for one of their new developments we're doing with them, they are taking over paying the tenants' electricity bills for the first time. And we're going to wire their solar into the common meters and then send the excess to offset the tenant meters as well. So that's one way that you can kind of salvage the townhouse or scattered site model, is to eliminate that landlord-tenant split incentive issue where that is most acute. But those are often some of the hardest for solar in Massachusetts right now. The next option would be, a 3 to 5 story mid-rise building. And in terms of what we're seeing, the common usage there with a lower common usage is around 60 to 80,000 kilowatt hours. That would be for an elevator, maybe some laundry, HRVs, heating and cooling for hallway spaces, et cetera. And in those cases, we can often offset around anywhere from 70 to 100% of that common usage with what the rooftop can provide. And then in the last case, we have those mid-rise developments, 40, 50 units plus, where we're able to offset only 20 to 40% of a much larger usage. And in this scenario, this is where the developer has actually gone ahead and moved to a VRF central heating and cooling system, which we're seeing on, I might say, like 10 to 15% of the developments we're working on right now. And in these, or if you have a senior facility for senior affordable housing where you have much more of the load on common for the building already anyway, because your seniors are not going to be paying their bills, that's another example where we'd land in this third category. And if you're interested in more resources on how we think about and calculate this and what the best practices are for landlord-tenant issues and all that, we've written a handy blog post that is located on our website, and you'll be able to access this link after the presentation to learn more about it. And lastly, in terms of what type of information do we need to do this estimating, this is often what it looks like, where you will have actually a list of the equipment running down for each building. In terms of what are the types of equipment that are being loaded in. As you can see, air conditioning, far and away the largest usage here in terms of kilowatts. And then we would use that to create an estimate of kilowatt hours per year, where this would show the hours per year runtime. So we take the hours per year, we multiply by the kilowatts, and that gets us to kilowatt hours per year for each unit. As a general estimate. So often we will provide this, and we will just have electrical engineering teams provide us with this information of just the kilowatts and the names of the equipment at the time that we look into this. Next item is very quickly just to talk through structural and racking, so people have an understanding of how solar goes on the roof. Very quickly, there's 2 ways that solar most commonly interacts with buildings. You have a ballast mounted system that rests on a flat roof, weighs often in the realm of 6 to 9 pounds per square foot, and is the best option for flat roofs because there are no penetrations. It is simply held down with ballast blocks on the roof. And this is generally cost effective, but has a little bit more in the way of weight. So it's very important early on for a solar ready roof to make sure you have at least 10 pounds per square foot of additional dead load capacity to be able to plan for a ballast mounted array. In many cases, we have clients come to us with a flat roof where they say we only planned for 6 or 7 pounds per square foot of additional dead load. And sometimes that works out based on the exact design of the array. Other times we have to do some penetrations where it would be mostly ballasted, but might require a few penetrations to meet wind loading requirements based on the specific design and uplift characteristics of the roof. So that's where we often can find the need to have a mechanical attachments holding panels down on a flat roof where we're more restricted on the weight limit. Now, the benefit of mechanical attachments, because you don't have all those ballast blocks weighing it down, the total system is really just the rack and the panels. So that's only adding closer to 2 to 3 pounds per square foot. So you can think about the extra weight here is mostly the ballast blocks. And then this is the weight of the actual equipment itself without all that extra ballast. So this can be is the only option for sloped where you do need to mechanically attach to the rafters and beams and make sure that your system is well integrated. And for flat systems, occasionally you'll need penetrations depending on the size of the system and other characteristics. There's a final option that we're seeing for some new construction buildings. This is what's called the wavelet racking due to its lovely wavelet design. One thing that's nice about this design is that it's basically our most energy dense solution. So some rooftops that we're trying to maximize the power output from, we might choose this wavelet design. And the trade-off is that because the panels are more densely arrayed and there isn't basically often, 12 to 14 inches of inter-row spacing. Here, there's basically 0 inter-row spacing between each panel. And the trade-off is that this system weighs more. So you'll have 10 pounds per square feet, and I've even seen it up to 12. And so often we'll choose this outcome where we're looking for maximizing output per square foot. So this would be particularly City of Boston energy positive buildings are circumstances where it's important to take a look at this because the E+ target is so aggressive that we have to produce so much energy in such a small amount of square footage that an option like this can be good. And we have to plan for that extra structural load from the get-go to make sure that that's not an issue. And these can be either ballasted, you can't quite see here, but there are trays that ballast blocks can go in underneath, or they can be mechanically attached as the two ways that this can interact. And if you do mechanically attach them, you can lower the weight, but with the trade-offs that comes with. One additional item that we wanted to introduce here is to talk through battery storage. So one question we get a lot is, solar's great, but when the power goes out, the solar turns off. And so we are not achieving a resiliency benefit. So in terms of batteries, this is an example of a commercial size battery installation that we completed recently. The benefits, of course, are resiliency, which is as long as your battery is installed with an automatic transfer switch, when the power goes out, that switch gets tripped, similar to the type of ATS switch that you would see with a generator. And your building is able to continue operating on a more limited basis with the battery that has been fully charged by your solar. Are that while there are some financial incentives for batteries, notably that it's still eligible for the 26% tax credit that the solar is eligible for currently. And it gets some additional incentives called peak and other types of state incentives. They are not enough to fully cover the additional cost introduction into the cash flow. So compared to solar only, batteries are kind of a net drag and a significant capital cost increase. So those are some of the trade-offs, but it really depends on, is it worth it to buy the extra resiliency benefit? A question we often get is, can batteries fully replace a generator? Because wouldn't it be nice to not have that generator and have all of the environmental compliance issues that come with having a combustion item and the venting requirements and all sorts of other stuff? And the answer, unfortunately, is no. Under current building code, battery storage is not deemed to be long-lasting enough, a source of backup power to fully replace a generator and meeting the sort of life safety issues that you have energy storage as part of a new construction building for. So battery storage in many cases needs to act as a supplemental source of resiliency for a lot of larger new construction buildings for that reason, which still can be useful. So that's some of the significant benefits and trade-offs. And another issue is right now it's enough that battery storage does not always work well with third-party financing models, making no-cost options somewhat more challenging, meaning you might likely have to buy the system and include it. The last item is, of course, that permitting and siting have continued to be significant challenges with battery storage. And the main reason is that battery storage, the main technology is lithium ion, which can, there's many safety features involved, but can catch on fire. And so from a fire department and building permit and regulatory standpoint, right now we do not, because the technology is new enough in its widespread adoption. It is a little bit case by case with cities and towns in Massachusetts in terms of how this is all being regulated and implemented, and there's new information coming out all the time. The general rule of thumb is that batteries are much easier to permit outside than they are inside, which generally makes sense. But and as you can see here, this installation that we're completing is in a exterior, paved area outside of a large commercial building where they did have that space. Often affordable housing is very limited in terms of exterior ground space, where, a cement pad mount plus this battery might even be able to be located. So those are some issues, but exterior can work much more easily than interior. So that's our recommendation for clients who are really looking for this, is to try and find sites where they do have an exterior location. And then lastly, in order to help defray the costs of looking into this, the Clean Energy Group provides us up to $7,500 in a technical assistance budget, and we have worked with many clients to look into this. So if there are specific sites where you're very interested in battery storage and resiliency for one reason or another, there is some grant funding to help pay for the upfront engineering in order to be able to figure out how big a battery do we need and what sources might it back up and how will it integrate and support our building. So that is batteries in a nutshell. And I wanted to show you, this is one of the finished projects that we are just in the process of commissioning right now. This is for a commercial manufacturing facility up on the North Shore in Methuen. We have about a 600 kW array on the roof and about 1,000 kilowatt hour battery or a megawatt hour battery located right here that is helping to use the power there and provide some critical backup for the facility. So lastly, we're going to move to, I want to leave some good time for Q&A session here to make sure that we can talk through some specific examples. And the last item I want to talk through is how to work with Resonant. And before I get into the mechanics, the first thing I wanted to mention is that for new construction, there's really two ways to work with us. There is working with us directly, which I would say 90 to 95% of our clients do, where clients will hire a GC to build the building, and then they will separately hire us under a turnkey agreement, either to purchase or through a third-party finance agreement to go with a no-cost option to install solar. And there's a few reasons why we generally prefer to be engaged directly. One is that the solar, unlike most of the other aspects of your building, has a bunch of legal and financial complexity to it in terms of the tax credit, monetizing the value, working with your senior lenders to underwrite the savings, et cetera, et cetera. There's a lot of more complex points that it helps for us to have a direct line to the development team to be able to navigate. And are we going with a no cost or an ownership option? All important questions for us to be able to answer together. So that's what I would say is the way we typically engage is that way. Another side benefit of that, of course, is that you are system can be really special. So that's another side benefit. And lastly, there's sometimes a concern from developers that we might lose out on coordination with the GC. And for reasons that I'll go over, new construction solar really can't be built until the last month or two of your new construction cycle. So by the time that we're involved, our building is effectively done. So in terms of the level of coordination, we do some upfront coordination, design and planning, and then realistically we come out right at the end to complete the installation, and the level of coordination, the contractor and the overall building is fairly minimal. That we have worked through DCs as well, and are working with Haycon on it right now in the city of Boston. So we have done that and it can work, but with those caveats that there's a little bit more part involved in the chain of communication around how this whole process comes together. So once you've decided whether we're working through the GC or not, this is our general process for how we work with new construction buildings. The first step is that our clients provide us with intake information and building drawings. We review all of that, and our team puts together a design and an economic analysis for how that could work with both a purchase option and a no-cost option. Usually takes about 2 weeks to turn that around. And from there, that proposal also comes with a letter of intent, and clients can choose when to move forward with that letter of intent, and includes a small design retainer to bring us onto your team. From there, once a letter of intent is signed, we our engineer and we create our initial design that can get sent over to the architect and integrated with the building plans. And we go through a little bit of the electrical integration of how we're going to hook things up. Clients then sign a contract, often 3 to 4 months later, sometimes longer, depending on how early we get engaged in the development cycle. And from there, we deliver the PV solution at the timeline that works best for the client. Another key piece and a reason to hire us directly is that there's often some time sensitivity in terms of how and when we sign contracts relative to locking in the federal tax credit for solar, and the first come, first serve SMART program incentives. And so all that requires some documentation and back and forth with the owner that, again, can work through the GC, but is often a little bit more complicated. And the last thing I'll say, just in terms of the is that we have to have all the roof needs to be fully installed, certainly before we come out. HVAC needs to be in place, plumbing work needs to be done, and permanent power all needs to be brought to the site before we can come out and complete the installation. So for all those reasons, that usually is what brings us to the last 2 months of the construction for the building. And in order for us to get in and do our construction before we have before the building is occupied, that actually requires developers and GCs to really prioritize getting that HVAC and those plumbing vents through to the roof done early. And sometimes we hit delays and HVAC is still being installed right before occupancy, and that can delay the solar installation and require us to wait and do the installation after occupancy, which I would say happens in maybe 1/3 of cases realistically. It's not our goal. There is a slight imposition to having ongoing construction happening while the building is occupied, where we have to, coordinate how we're going to use the parking lot for the first day for delivery is usually the main issue, and some other small logistics that we will go through in later presentations over the course of this summer. But just to say that prioritizing getting your HVAC and plumbing work done is very critical to being able to install while the building is still a construction site and not occupied. So in terms of our new project intake process, we have a new construction webpage that includes our intake sheet and submission process. The types of information that we like to collect are the groundbreaking date and overall project schedule, what type of tax credits you're going for, whether financing is closed or pending, if you're targeting different building certifications. I'd say at least half of our new construction buildings we're working with right now are targeting a Passive House 2018 or 2021 certification, what type of electric service you have, the target solar output, if there are any specific that we need to be aware of, some means of estimating common area electric usage, which we have discussed, and of course, drawing sets, which ideally we just get the whole plan set, or we need the roof, structural and electrical drawings, and elevations, generally speaking. So that is our process where we collect our data and turn around your analysis to you at no cost within 2 weeks, and then can proceed from there. So that brings me to the end of my presentation. We got about 15 minutes left, and I would love to hear some questions from the group to see what we can cover. Thank you all for taking the time here. All right. So to open it up, it looks like we have one question got answered, and I'm going to follow up with that now here. And this is from Maureen. So just to reiterate, the question was really about when to engage. So our projects are sometimes required to complete solar feasibility studies as a condition of securing affordable housing financing, which would be well before 70% designs. Do you offer those feasibility studies to predict estimated production versus cost and recommend ideal placement? And this has already been answered by my colleague here, but what I would say is, if it's needed earlier at a more conceptual phase of the design, we absolutely can provide that earlier and can update it as we go, noting that it will be very preliminary from the outset, but that is something that we're happy to help clients with by providing that at an earlier stage. So the short answer is yes, we can absolutely accommodate that. Let's see, and looking at a few of the other comments here, we've noted from Lisa Wolf that battery storage can sometimes get utility incentives since it reduces capacity and transmission. And that is a great point. And I hope that I did not say that battery storage would get no incentives. And I guess what I wanted to emphasize is, especially right now, batteries are expensive enough, and the way that utilities are providing incentives are not enough to kind of fully justify the cost of the battery on a strict return on investment basis relative to solar. So batteries can be a good option, and there are some incentives for it that help to justify it. But in our experience, there really needs to be a strong drive towards resiliency and a willingness to put some dollars in that direction as another key piece of the puzzle. And I will give another few moments in case we have anything else, but otherwise I'll just say thank you all for joining. And I hope that this was helpful as you're thinking about integrating solar into affordable housing. And I will also apologize if there was any choppiness with my internet connection. This presentation is going to emailed around to all of you, so you will have the links and the source information as well. And let's see, we have one more question here. Let's see, and Emily, maybe you want to come off mute and ask this question? Hearing none, I think that we, since I don't fully understand the question, we are going to move off of that one. So I think what I'll do for now is I will close. What I wanted to offer is just in closing an appreciation for you all joining, and we will be in touch. My email is in the presentation. So I hope you all have a good rest of your day, and thank you for tuning in. Oh, and it looks like, let's see, just one moment ago, Latifa asked one question. So we'll just say, what percentage of affordable housing projects are using solar? I would say probably it's trending up north of 50% now, would be my general guess, in case that's helpful and you're still here. Thank you all. We'll be in touch.